Hello everyone, welcome back to the Quant Tutor. Today we'll be doing question number 8 of the June 2022 P1 paper. Alright, so the first question is asking us to find the gradient of line L1, right? We already have uh, the equation here, right? So all we need to do here first is we want to rearrange this equation, right? So some of you might know, right, or you might have learned already that the equation of a line is written in this format. So this is the standard equation of a line, right? And we have m, which is our gradient, right? So for us now to be able to find this gradient of line L, all we need to do is we need to rearrange this equation to make it look like this. And then we basically identify what is the m in that final equation that we have, right? So let's start by taking y and putting it on the other side, right? So what I'm going to do is I'm going to move 5y and I'm going to move 5y this side, right? So what I'm going to get is 2x minus 5y, sorry, 2x plus 7, right? Because 7 is remains here, is equals to 5y, right? So 5y is moving here, okay? And now I'm just going to swap the places of both of them and say that 5y is equals to 2x plus 7. Right? Now I'm going to make y the subject, right? Which means I will get 2x plus 7 divided by 5. And the way I can write this is if you have a numerator dividing with one denominator, you can separate them out and write 2 over 5x plus 7 over 5, right? And now all we need to do is match this to this, right? And you see that the coefficient of x, so whichever number is in front of x, will be your gradient. And in this case, we have 2 divided by 5, which is in front of x. And so our final answer, so our gradient of L, gradient of L1 is 2 over 5, which is our final answer. Now let's move on to part B. Right? So part B is saying that the point A has coordinates 6 and 2, right? Okay, so we know that there's a point A somewhere, right? And we know that the line L2 passes through LA and it's perpendicular to L1, right? So now let me just draw like a random graph, okay? It may or may not be what it's supposed to be, but it's good to visualize these things. So let's say that you have a normal line, let's say the line is called L1, right? Maybe it looks like that. I don't know, right? You can just assume to be what it is. Now they are saying that L2 is perpendicular to this, right? So L2 is something like that, right? It's perpendicular, and L2 is passing through A. It doesn't say that L1 passes through A. It just says L2 passes through A. So let's say maybe A is this random. Okay, so like I know that this point goes down here. So we know that it's 6 and minus 2, right? So we can say that this is 6 and minus 2. Okay, let's say that this is point A, for example. Now, what we are supposed to do is we want to find the equation of line L2, giving your answer in the form of y is equals to mx plus c, right? Now, the first thing to do here, we can use this equation to get the equation of a line from one point, right? And the equation is like this. So y minus y1 is equals to m times x minus x1, right? And y1 and x1 are just these points that we already have, that we know that the line is passing from. Okay, but the only thing that we don't have here is the m, right? And the way that we can get m is by reading this line that says that L2 is perpendicular to L1, right? So we know that when a line is perpendicular to another line, right, the gradient will be negative the reciprocal of it. So we know that the gradient of L1, the m of this was 2 over 5, right, from part A. And so the gradient for L2, so the gradient of L2 will be minus 5 over 2, right? So which is minus the reciprocal, which is the reciprocal of 2 over 5 is 5 over 2. right? So there we go. So now we know that this is equals to m, right? Now I'm just going to input these values in. Okay, so I know that I have my y. My y1 is minus 2, which we've is the point A. We know this. So minus 2 minus, so it's basically plus. We know that the gradient is minus 5 over 2. We know that this is x, and then x is 6, right? So let's expand this equation out. Okay, I'm going to write it here. So what this is going to be is it's going to be y plus 2 is equals to minus 5x over 2 minus, so minus 5x times, so minus minus will become plus here, right? And 6 5s are 30. 30 divided by 2 will be plus 15. Okay. Now what we are going to do is, all we need to do is we need to take the plus 2 and move it that side, right? The plus 2 will go that side and it will become minus. So 15 minus 2 is 13. And then our final answer will be minus 5x over 2 plus 13. And there we go. We have the equation of the line exactly how they asked, right? In the exact format that they asked. And so here we are done with part B. Let's move on to the next part, which is the part C, right? So now we know that L1, we know the equation of L1 and we know the equation of L2, right? Now what they ask next is, using algebra, find the coordinates of M, right? And we know that M is the point where both these graphs intersect. What I'm going to do is I'm going to take this equation, I'm going to take this graph that I drew, right? And I'm going to get that to here, okay? I'm going to get that here. So now we have this graph, right? So what this question is telling us is that we want to find point M. So this is point M, right? Where they both intersect. Yeah. So we know that the equation of line L is equals to y is equals to 2x over 5 plus 7 over 5, right? So this is from the previous question. You can rewind and refer this back from part A, and then from part B you can see that the equation of L2 is basically y is equals to minus 5 over 2x plus 13. So when two lines interact, we know that at this point their y value and their x value is the same, right? So we can equate these y values together. We can say that these two y's are equal, and then I'm going to substitute this here, right? So what I'm going to say is I'm just going to equate these two equations together, and it will basically be plus 13 is equals to 2x over 5 plus 7 over 5. Okay. Now I'm going to get 2x over 5 that side. Sorry, I'm going to get 5 over 2 that side, and I'm going to get 7 over 2 this side. Okay. And then basically what that's going to be is that it's going to be 2x over 5 plus 5x over 2, right, is equals to 13 minus 7 over 5. 13 minus 7 over 5, right? And the way that we can do this is, if you use a calculator, you can say that 2 over 5 plus 5 over 2 will give you 29x over 10, and will be equals to, and 13 minus 7 over 5 will give you 58 over 5, right? Now I can just cut these two out. So I can say that 29 multiplied by 2 is equals to 58, and 5 times 2 is equals to 10, right? And so what I'm going to be left is that x is equals to 2 multiplied by 2 here, which is 4. Okay, so now I know the value of my x. So let me make this a little bit small so that we have space to find y as well, right? So now I know the value of x here. I'm just going to move this and put it somewhere here. Okay, now we know that x is equals to 4. We need to find the point y now, right? And now you can input this x value either in this equation or in this equation. Both works just well, right? So I'm going to input into this equation just because it seems a little bit simpler since we already have an integer here, right? So I'm going to say y is equals to minus 5 over 2 times 4 plus 13, right? So 2 times 2 cut, it becomes 2, right? And then minus 5 over 2 is minus 10 plus 13. And so y is equals to 3. That means that the coordinate of m is 4 and 3. There you go. Right? So we have this part of the question done. Now let's move on to part C. So before moving on to part C, actually, I'm going to copy this diagram again. Okay, just so because we'll be using it there. So I'm going to copy this and I'm going to paste this here so we can use it as our reference. All right. So part C is saying that given the diagonals of a square A, B, C, D meet at M, find the coordinates of the point C. Right. Okay. So now we already know point A, right? We know that point A lies somewhere here. Right. So I'm going to draw this diagram again using the reference of that. So you can do this actually without doing any calculation. You can just visualize it and see how it is. So there are actually two ways to do it, and I will show you here. So now we know that point A is 6 and 2, right? This was given to us in the question. Right. So 6 and 2 is somewhere here. So this is 6 and 2. Right. 6 and minus 2. Sorry, okay. So this is 6 and minus 2, and this is point A. Now we know that these two lines cross at point M, right? And we know that, okay, A, B, C, D, right? So B could either be here or B. So if it's a square, it will basically look like that, right? My drawing is not the best, but you have an idea that a square looks like that, right? And we know that point B could be here or here because it could be A, B, C, D, right? That doesn't matter. But the key thing that we know is that the point C is opposite point A, right? And now if I draw the diagonals of this square, it's basically going to be like this. And let me just change this to D so that you all don't get confused, right? So it's an ABCD triangle. Now we know that this point intersects here. Sorry. It intersects at some point here. So this is point M, right? And we actually know the the coordinates of M, right? Which is 4 and 3, which we just found in the previous question. So now there are two ways of doing it, right? We can do normal because we know that point M is a midpoint of C and A, right? And so all we need to do is if we know the equation of a midpoint, you can say that, it's x2 plus x1 divided by 2 and y2 plus y1 divided by 2, right? So let's try doing that first. Let's try the first method, right? And then I will do a second method with you that is a lot easier. Okay, so method 1 says x1 plus x2 divided by 2, y1 plus y2 divided by 2, right? So our x1 is, okay, but we know now that, okay, let me make this smaller. Okay, just let me hide this somewhere here, and then let me move this up. Okay, so we know that the midpoint here is 4 and the midpoint here is 3. So what we're going to do is we're going to equate, and we know that, let's assume that A is x1, right? So x1 plus x2 is actually the x of C, right, that we're trying to find, divided by 2 is equals to 4, right? And then in another case, we know that y1, which is A, y1 plus y2 divided by 2 is equals to 3, right? So now when you solve this equation, you get 4 times 2 minus 6, right? So you get x2 as 2, right? And then you get x1 and you get y2 as 3 2s are 6, 6. So this multiplies together, 3 times 2, and then 6 plus 2 because 2 goes outside, right? The negative changes to plus, and this becomes 8. So your answer becomes 2, 8, right? So this is basically the midpoint, right? And that's why you can say that, sorry, 4 and 3 was a midpoint, and then you're using the midpoint to find this, and you can say that C is equals to 2 and 8, right? So this is one method of doing it. Now I'm going to, you guys can take a screenshot of this or you can make a note of this because I'm now going to cut this out and do method 2. Okay, so the method 2 that we are going to use is more logical. Okay, so method 2 is a lot more logical and a lot more observing what's going on here. We know that this is a square, right? So we know that this is a square and this is 6 and this is minus 2, right? And we know that this point here is 4 and 3. Oh, I've already written it here, but it's 4 and 3, right? So now I know that the x distance between this midpoint here and this is 2, right? Which means this will also have to be 2. So we automatically know that the coordinate of D, right? D will be in the same y as A, right? Because the y value is the same. And we know that the x value is 6 minus 2, which brings us to 4, and then minus 2 again, which brings us to 2. So I know here that point D now is 2 and minus 2, right? So I can just deduce the point D by using my logic of how a square works. Now let's do the same thing for C, right? Let's translate this whole thing up. Now I know that this is 3, right? And I know that this is minus 2. So I know that this is minus 2. And I know that this point here is 3. My diagram is not at the exact place, but just bear with it. So now you know that this distance here means from D to the midpoint is 5, right? So that means the other half here has to be 3 plus 5, right? So it's also 5 here. So it means that it's 8, right? And we know that the x of C is the same as D, right? Because it's a straight line down. So we know that C's x is 2. And now deducing this, we know that C's y is minus 2 plus 5, right? Plus 5, right? So plus 10, which will give us 8, which is the exact same answer as what we got with our method 1, right? So you can choose which method you want to do. Both are correct, whatever you're comfortable with. If you do this method, make sure that you're also drawing a diagram and you are also showing the examiner how you got this value, right? In order to make sure that you get all the points. So there you go. We are done with question number 8. If you have any questions or if anything was not clear, feel free to drop a question in the comment box and I'll make sure to answer it. And if you like the video, please don't forget to like and subscribe. And we'll be back with question number 9 very soon.